let's consider the following function. F of z is equal to minus 1 over z minus 1 times z minus 2. And we are going to find the Laurent series around the point z 0 equal to 0. What we are doing is to replace this function by a sum of two less complicated functions on this form. So a and b are constants which we are going to determine. The way of doing this is just to multiply with this product on both sides of this equation, and then we obtain minus 1 equal to a times z minus 2 plus b times z minus 1. And by inserting, for example, z equal to 2 into this equation, then we eliminate this term. So we obtain the equation minus 1 equal to b times 2 minus 1, and this gives the following, that b is equal to minus 1. Similarly, by replacing z by 1 in this equation, we obtain the following. We obtain that this term vanishes, and we can determine the value of a. So we obtain that minus 1 is equal to a times 1 minus 2, and this gives us that a is equal to 1. So this means that our function f of z can be written in the following way. We now replace a by 1 and b by minus 1 and obtain this simplified expression. It may not look so much simpler, but it turns out to be much simpler expression regarding finding the Laurent series. So let's start by now finding the Laurent series of this term first. We know that we have several Laurent series in different regions. We're going to come back to this later on, but let's now start with the following. We find that this first term, 1 over z minus 1, is equal to this series when z is less than 1, and this series when z is larger than 1. I mean, the absolute value, of course, is larger than 1. And well, we have seen this before because this was in a previous example. And we also have seen that 1 over z minus 2 is equal to this infinite sum. For the case when absolute value of z is less than 2, and this series when the absolute value is larger than 2. So how can we now find the Laurent series to the sum of these two functions? Or in fact, it's the subtraction between these two functions that we have given the Laurent series for. If z is larger, is less than 1, the absolute value is less than 1, we can call the region the red. We can make this color for this region. So in this region we have that absolute value of z is less than 1. So it's this circle as radius 1. The next circle we're going to consider is the circle with radius equal to 2 and center at the same point 0. So we have to find the Laurent series in this region, in this yellow region, and in this green region. Because as we see, we have Laurent series in these separate domains. What we're seeing here first is that for set, an absolute value of set less than 1, then we have this series expansion of this first term. And of course, in the same region, we also have this series expansion for this term. Because this disk, the unit disk, is contained in the disk, the larger disk. So it's obvious that we have the following expression, the red region, f of z is equal to this guy minus this guy in this red region, in the unit disk. In the disk between, or the ring region between these two disks, in this region, which we call the yellow region, then we have, let's go up and see, then we know that the absolute value of z is larger than 1, so this term should have this series expansion, and we know that this term must have this series expansion. So that's the reason why we have the following, that f of z is equal to this guy minus this guy. So I've just done what I just said, replace the first term by this series expansion minus this series expansion. And the last region, the green region, that is the region where the absolute value of z is larger than 2, then let's go back. Then we know that for this term we should have this series expansion, and for this term we should have this series expansion. So then the function f of z should be this guy minus this guy. And that's what we have written here. So now we have found the series expansions in these three regions: this red region, the yellow region, and the green region.